So today we are going to learn how to prove statements about segments and angles. This is lesson 6. So here is our first, official definition of a proof. And a proof is a logical argument that shows a statement is true. There are different formats for proofs. You could write your proof using a flowchart. You could write a paragraph proof or 2-column format. In this course, we will be writing proofs in the 2-column format. So that's what we're going to use. So we will have our column on the left will be for statements, and our column on the right will be for the reasons. Our statements will include either the given information, and then from there, how we would change from step to step, or the result of applying a known property or fact. Explanations must be given for each corresponding statement. And on the next slide, we're going to talk about valid reasons or justifications. So acceptable reasons in your geometry proof or even in your algebra proof could be, you could say that it was the given information, and you can get that given information either from a sentence or a statement, or you could also get your given from a diagram. Like they might have 2 angles with congruency marks or 2 segments. You can also list as a reason for proof definitions, properties, postulates, and theorems. Notice this little disclaimer here, previously proven ones only. And what this means is when we're doing a geometry or any proof from chapter 2 on this test on Tuesday, I don't expect you to use a theorem that maybe is in chapter 10 because we haven't covered that yet. So when you give me a reason in your proof, it has to be something we've covered in this course. So you have to use only definitions, properties, postulates, or theorems from either chapter 1 or chapter 2. Okay, so no jumping ahead. Now also remember, geometry is cumulative. So whatever we learn in chapter 1 is fair game on our chapter 2 test. And then when we get to the chapter 3 test, anything from chapters 1, 2, or 3 could be on the test. So nothing's going to go away. You can't just study for one test and then forget about the information. It's going to build throughout the course. So again, it's cumulative. So here are properties of congruence that could be applied to angles and to segments. These are the same properties we saw yesterday, but yesterday they had equal signs in between them. So we learned it as the reflexive property of equality, the symmetric property of equality, and the transitive property of equality. For your purposes on your proofs, I don't need you to state that this is the reflexive property of congruence. When you list it as a reason in your proof, you can just write the word reflexive or symmetric or transitive. You don't have to include property of equality or property of congruence when you're listing these 3. And you can use them interchangeably. The difference between what we learned yesterday, for example, with the reflexive property, the reflexive property of equality deals with the exact measurement. So for example, if I talked about segment DE, like they're talking about here, if I told you the length of DE was 4, then I could use my property of equality and say that 4 equals 4. Because if DE is 4 and I'm applying DE equals DE, then I'm talking measurements here. When I talk about the congruency symbol, that just tells me they're the same size. I don't care if they're 4 inches long, 10 inches long. I don't care about the measurement. I just need to know that they're the same size. So that's the difference between the equal sign and the congruent symbol. Does that make sense? So, I'm sorry? Good? Okay, so again, same 3 properties we saw yesterday. Reflexive property is like your reflection in the mirror. It's the same thing equals the same thing. Symmetric is like the line of symmetry. And again, the order is mixed up. Then the transitive needs 3 pieces. Again, it's like your law of syllogism. These CDs would cancel out, and then you can go to the conclusion that AB is congruent to EF. And you can apply the same thing to angles. Okay, then it has an example of a proof. So this is potentially a test question where I'm going to give you a diagram and you're given. I'm going to ask you or tell you what you're trying to prove. Remember, your last statement in your proof is going to be this. However, you do need to provide justification or a reason for that statement. Now, this is how you're going to get the question on the test, is I'm going to give you a partially filled in proof. So right now, all I've provided is the statements. You have to give me all of the reasons. Now on the test, I might give you a statement and you give me the reason, or I might give you a reason and you give me the statement. So at the beginning, when we first write proofs, you don't have to do the whole thing by yourself. Probably on the next test or quiz, you will be writing the entire proof by yourself. So let's go ahead and see if we can figure out what our reasons are for this example. So number 1 should be the easiest one for you, and that is given. Now, when you go to take this test Tuesday, I shouldn't see that answer blank. Everybody should get that question right. You should be able to tell me that number 1 was given because it's right here, and it's right next to the word given. So when you're doing your proof, everyone should at least get that part of the proof right, is giving me the given back. And then also you should be able to at least give me the last statement, maybe not so much the reason for it, but you should be able to also give me the last statement in the proof. Now, everybody's proof will be different. Some people may end up coming up with a different logical order. However, when the statements are provided, we're not going to modify that. You have to give the correct justification. And there's not going to be more than one answer for these. So, step number 2. Anybody have an idea of what they've done there? What we learned maybe back in chapter 1? Yes?
Originally, I thought it was segment addition postulate, but it has to be angle addition postulate.
Beautiful. They are using the angle addition postulate because they are adding angle 3 plus angle 2 to make up the whole angle of EBA. So for this, you can abbreviate it if you'd like as AAP, or write out angle addition postulate. Anybody have any idea what they did from step 2 to 3? What's different? Good. Angle 3, the measure of angle 3 was changed to the measure of angle 1. And if you go back to step 1, look what they told us. They told us that 1 and 3 are equal. So what do you think they did? They substitution. And then step 4. Now we're talking about a different large angle. They're talking about DBC, and DBC is over here. And they're telling us it's made up of angle 1 plus angle 2. Anybody have any idea what that one is?
Maybe substitution? Because we know that on top it's the same thing.
Okay, but do we know anything about DBC yet? That's what they're asking us to prove.
What are they asking?
To prove that the measure of EBA is equal to the measure of DBC. They're using angle addition postulate. So they're trying to establish what DBC is made up of. And DBC is made up of 1 plus 2. And now we can say angle addition postulate here. And now we can do substitution. because both DBC and EBA equal 1 plus 2, so now you can say substitution. Now you wouldn't say transitive, because transitive would have needed only one piece of information. So this is substitution for the last step. Okay, he just asked, can you list just the postulate number as a reason? So you can't list as a reason postulate number 10. You would have to actually write out the sentence of what postulate 10 says. Okay, so again, we're not memorizing the postulates by number, we're memorizing them by what they state. And you will state that as a sentence as a reason. All right, example. Again, we're writing a 2-column proof. This time, our given is AC is equal to AB plus AB. So again, our first statement, the reason for that is it was given to us. Step number 2, AB plus BC equals AC. Anybody have any idea what we're doing here?
Is it the segment addition?
Beautiful, segment addition postulate. And again, you could abbreviate that as SAP if you want. Or write out the words, segment addition postulate. All right, step 2 to step 3, they're doing substitution. Notice they're taking out this AC and they're putting what AC equals, which is A plus AB plus AB. And then they just rewrote this over here. They flip-flopped the places. So this is substitution. And now, our last step from 3 to 4.
Elimination.
What did they take away? But all right, elimination. What's a property for elimination? Begins with an S. Subtraction. So they're subtracting AB from both sides, and then now they're just left with AB equals BC. And this is the subtraction property of equality. Go. All right, so this one, they're giving us that M is the midpoint of AB. So again, our first statement is given. Now, the next one, number 2, AM is congruent to MB. How do we know that?
Because the given told us that.
Okay, what's the given?
M is the midpoint.
And what does a midpoint do?
It slices in half, it's equal to.
Good. So by definition of midpoint, we can make this statement.
What does that even
I'm leaving you guys. My God.
The definition of a midpoint states that if you have a midpoint of a segment, it splits it into 2 congruent pieces. Now, the third, from step 2 to step 3, if you were writing your own proof, you wouldn't need to include this. All we're going to do here is, if you notice, they've just taken and changed the congruency symbol to an equal sign. So if you're writing your own proof, you don't need to show that. So the reason here would be definition of congruent segments. Now, if this were a test question and that statement is there, you would have to justify it by the reason I just told you. However, for your purposes, you could jump from step 2 to step 4. You don't have to change that congruent to an equal sign. Yes?
On the test, will we have to prove that it, like what you just said, will we have to write that as?
You might, because I'm giving you the statements.
Okay.
All right? What's happening in step 4?
Segment addition.
There you go. Segment addition postulate. Step 5. Cynthia, you got this one?
the MV for AM?
Beautiful. Substitution. They're substituting in the MB for with an AM. Yes.
Could 5 also be definition of midpoint?
No, because we're not showing two congruent pieces.
Yeah, but we know if they're the same, then you could, no?
No. This one was a substitution. What they did was they took out MB and then in place of it they put AM. Because right above it, we were told that they're equal. Yes.
Where's like the segment addition postulate, like in the lesson?
That was back in chapter 1.
So
All right.
what lesson should we look at?
All right. So now, from step 5 to step 6, all they did was add 1 AM plus 1 AM and got 2 AM, so that's simplified.
Oh, I thought it was
That's a
addition.
freebie, we take those.
So addition property of equality would have been if you added something to the other side also. But when you just combine like terms, we're just going to say simplify. And then the last step, you can either say,
Division, I put division, property of equality.
good, you could either put division or multiplication. You're either dividing by 2 or multiplying by the reciprocal. So for that last step, I would take either or. You could say either division or multiplication, property of equality. So next slide, you're just going to be in. It's talking about writing a 2-column proof. So in a proof, you're going to make one statement at a time until you reach your conclusion. And you're going to make your statements based on facts. You're going to be using deductive reasoning. And then every time you write a statement, you have to justify it and give a reason. So again, generally, always your first statement is going to be the given. Also, remember your very last statement is what you're trying to prove. And you have to justify it. So I shouldn't see anybody's proofs blank. You should all be able to put in the given and then also give me the proof. And then from there, try to fill in the rest of it. But again, on the test, I'm going to probably give you the statements and you're just going to give me the reasons the first time. So for Tuesday's test. So that's it on this.